Hydrocarbons are those organic compounds which contain hydrogen and carbon atoms. Alkenes are those compounds which contains carbon-carbon double bond, and alkanes contains carbon-carbon triple bond. Suffix of alkanes, alkenes and alkynes, they always come in the suffix and they will be never present as the prefix. Once hydrogen is added, the double bond will be broken down. So what happens here is you have two hydrogen atoms, right? So this bond will break. One hydrogen atom goes here, one hydrogen atom goes here. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. Today's session we are going to study about the introduction to hydrocarbons, right? What are we going to study in hydrocarbons and which type of compounds are called as hydrocarbons, all those we are going to see, and then the important classification of hydrocarbons. So this is quite familiar with the classification which you have already studied in organic chemistry chapter, and then the methods of preparation of alkanes. So all this we are going to discuss in this session. So let's begin with the chapter name itself, hydrocarbons. What are we going to study in this chapter? Hydrocarbons. So from the name itself you can identify hydrocarbons. So hydrocarbons are those organic compounds which contain hydrogen and carbon atoms. Okay. So hydro stands for hydrogen, carbon stands for carbon, right? So together hydrocarbons, we are going to study about the organic compounds, okay, which contains hydrogen and carbon atoms, right? So let's see, hydrocarbons are a group of organic compounds containing carbon and hydrogen, right? Now we are going to study about the classification of hydrocarbons, okay? So after classification you will understand which are the different types of hydrocarbons, and based on that in detail we are going to study about the method of preparation, their physical properties, their chemical properties, all of that, right? So let's begin with the classification. Majorly they are classified into aliphatic, alicyclic and aromatic hydrocarbons. So aliphatic hydrocarbons, you already know this, aliphatic organic compounds you have studied. So those are organic compounds or hydrocarbons in this case which does not contain any cyclic structures, right? They are also called as open chain structures because they do not have any cyclic structures. The next one is alicyclic, or else you can also call it as cyclic hydrocarbons, which means that they have cyclic structures. And the third one is aromatic hydrocarbons. So this aromatic stands for benzene containing compounds. Why they are called as aromatic? Because they have a particular smell. Okay, so aromatic compounds are the ones which contains benzene containing compounds. So let's move on to the classification of hydrocarbons. So hydrocarbons are broadly classified into open chain or acyclic. That means it is open chain compounds which does not contain any cyclic structures, and also the other classification is closed chain or cyclic, right? Okay, so open chain or acyclic is further classified into saturated and unsaturated, right? So that is which is does not contain any cyclic structures. So there are two classifications under that itself. First is the saturated hydrocarbons. So under saturated hydrocarbons you have alkanes. So alkanes are those hydrocarbons which contain only single bonds, right? The next one is unsaturated hydrocarbons, that is alkenes or alkynes. So you are already familiar with this. So alkenes are those compounds which contains carbon-carbon double bond, and alkanes contains carbon-carbon triple bond. So alkanes, alkenes and alkynes come under the open chain hydrocarbons. Next one is closed chain or cyclic structures. So in this you have two types, alicyclic and aromatic. So in alicyclic you have cycloalkanes or cycloalkenes. So for example, this is example of a cycloalkane. So this is hexane. So is this benzene? It is not benzene because it is not having alternate double bond. So this is just an alkane which is present in a cyclic structure. So it is prefixed by the name cyclo. So the name of this compound will be cyclohexane, right? Cyclohexane because it is having 6 carbon atoms. Now the next one is aromatic hydrocarbons or arenes. So these are which contains the benzene compounds, right? So this is the benzene structure, okay? So this is the classification of hydrocarbons. Now aliphatic means these are the hydrocarbons containing open chain of carbon atoms, okay? No cyclic structures, only open chain. So first one is saturated hydrocarbons. So these are hydrocarbons which is containing only carbon-carbon single bond, right? Carbon-carbon single bond. So for example, and they are called as alkanes. and they are called as alkanes. So examples are methane, ethane, propane. For example, CH4, methane, that is CH. So in this you can see it is all single bonds, right? Yes. Now moving on to unsaturated hydrocarbons. These are hydrocarbons which contains double bonded or triple bonded system. So the first one is alkenes. Alkenes contain carbon-carbon double bond, and alkynes contain carbon-carbon triple bond, right? So for example of an alkene, it is, let's take the example of the first alkene, that is ethene, CH2 double bond CH2. This is ethene, and another unsaturated one is alkyne, right? So the first one is ethyne, right? Okay. Now that is about alkenes and alkynes. Now we are going to study in detail about alkanes. So first we will study about the nomenclature, then we will study about the methods of preparation. How can we prepare alkanes from various other compounds? Then we'll study the physical property, then we'll study the chemical properties, right? And in the same way, we are going to repeat it for alkenes, alkynes and aromatic hydrocarbons, right? So let's begin with alkanes. So alkanes are the saturated aliphatic hydrocarbons which contain only carbon-carbon single bond. We already know that. And they are represented by the general formula CnH2n plus 2. So this is the general formula for alkanes, that is CnH2n plus 2. So what is the use of this general formula? If I want to write or if I want to find out the molecular formula of an alkane which contains, let's say, 4 carbon atoms, okay, so the formula will be, in place of N, I will substitute 4 now, okay, so C4H, 2 into 4 is 8, 8 plus 2 is 10. So I just have to substitute in this equation, I will get the molecular formula of the alkane. So this is the general representation. Fine. Now let's see, they are also called as paraffins. So that is another important point. They are also called as paraffins because it is having affinity towards solvents. Right. Okay. Now let's see the nomenclature. So nomenclature, the IUPAC nomenclature you have already studied in your organic chemistry chapter. So when we are going to study about the IUPAC nomenclature of alkanes, what you have to remember here is, yes, you know the root word or word root, which stands for, if you have 1 carbon atom, it is meth, 2 carbon atoms, it is eth, 3 carbon atom, it is prop. So you are already familiar with that. Now you have to use the suffix relating to alkane. So the suffix here will be ane, right? In the case of alkene, it will be ene. In the case of alkyne, it will be yne. So now we are going to study the nomenclature of alkanes. So the root word plus the suffix you have to use. The suffix will be a. And one more point is that suffix of alkanes, alkenes and alkynes, they always come in the suffix and they will be never present as the prefix. Right. So let's see. If there is 1 carbon atom, the root word is meth, right? And the structure is CH4, right? And the IUPAC name will be meth. And you have the ane, which is the suffix. So it will be methane, right? If it is 2 carbon atoms, the root word is eth, right? And it is CH3, or else you can condense it and write it as C2H6, right? So even this you are familiar with this. It is called as the homologous series, right? So all of this will differ with each other by a CH2 group. We have already studied this in organic chemistry. So it is called as ethane, eth plus ane, right? Ethane. Now 3 carbon atoms, it is prop, hence the name will be propane. CH3, CH2, CH3. So these two will differ with a CH2 group, right? Next one is 4 carbon atoms, it is bute, CH3, CH2 twice CH3. Now why it is written CH2 twice? So instead of expanding it and writing, we can condense it and write it in this form. That is CH3, CH2, CH2, CH3. So this 2 CH2s can be combined and written as CH2 twice. That's it. Okay. Next is 5 carbon atoms, root word is pent. So the name of the alkane will be pent and ane, pentate, right? 6 it is hex, so the name will be hexane, right? And 7 it is hept, so the name will be heptane, right? The next one is 8, so the root word is oct, so the name will be octane. 9 it is non, and the IUPAC name will be nonane. 10 is dec, and the IUPAC name will be decane. So you can see the molecular formula also here. So just by substituting in the general formula, you can get the molecular formula of the various alkanes. So I guess the IUPAC nomenclature is simple here. Yes, you just have to use the root word corresponding to the number of carbon atoms and suffix it with ane. Right. Now let's study the important part. which is the method of preparation of alkanes. So there are various methods with which we can prepare alkanes. So while we are studying the methods of preparation, you will find certain name reactions which are of course a little more important than the other ones. Okay, so let's begin with the first one from alkyl halides. So from alkyl halides, there are two preparation methods. So before moving on to the methods, first let us understand what is alkyl halide. Okay, so let's take the example of CH4. This is called as methane, right? So from methane, we are removing one hydrogen atom and we are substituting it with another halogen atom. So that can be fluorine, chlorine, bromine or iodine. Those are the halogens, right? So it is CH4. Now you are going to get CH3. I removed one hydrogen atom and placed another halogen atom there. So this is an alkyl halide, okay, which is the alkyl group here, CH3. So that is called as methyl. So this is methyl chloride. So this is called as alkyl halide. Now let's see from this how we can prepare. Okay, so the first one is by Wood's reaction. Wood's reaction. So is this a name reaction? So it is important, right? So alkyl halides reacts with metallic sodium in dry ether to form higher alkanes. So the reactant here, the initial reactant here is alkyl halides. So from alkyl halides, we are going to react it with sodium in the presence of dry ether. So in each of these reactions, we are going to study the reagent, the product, everything is important. Alright, so let's see. We are going to react it with sodium in presence of dry ether. So what is this Rx here? This is a general representation of alkyl halide. So R stands for any alkyl group. Yes, for example, in that case, R will be CH3, right? And the X is chlorine there. So it can be any alkyl group, CH3, C2H5, C3H7, any alkyl group, right? So 2 moles of alkyl group I have taken. One is Rx, another one is XR. It's just written in the opposite way. That's it. So in the presence of sodium and dry ether. Now what is the significance of dry ether? Dry ether is used because sodium reacts violently in presence of water. So there shouldn't be any presence of water. So that is why the reaction proceeds in presence of dry ether to remove any excess of water. Right. So what happens here is, if we write it in this format, it is easy to understand. This much part will be removed. That is 2 moles of Na, sodium, and 1x and 2x. You have 2 halogen atoms. So together it will form 2NaX. Okay. And what is remaining here? This alkyl group and this alkyl group. Now they will combine and form your alkane. You'll get your higher alkane. So let's take an example and understand this. Okay. CH3Br. Okay. It is bromomethane. Okay. So CH3Br, and in this case we have taken BrCH3. It's just the opposite. And sodium in presence of dry ether. So what happens? This much part will be removed as 2NaBr. Right, and what is left? CH3 and CH3 will be left. You got your higher alkane. What is CH3? CH3 to C2H6 ethane. Right, another example, C2H5Br. Again in presence of 2 moles of sodium. Again, I am writing it in the opposite way. BrC2H5. So, in presence of what? Dry ether. So, what happens here? This much part will be removed as 2NaBr. Right. 2NaBr, and which is the alkane you are going to get here? C2H5, C2H5. That is, together you can write it as C4H10, which is butane, right? So this is the Wood's reaction. Now another method of preparation from alkyl halides itself, it is by the reduction of alkyl halides. So what is reduction and oxidation? You already know this. So reduction means either it can be the addition of hydrogen or the removal of oxygen. So here we are going to see that we are going to add hydrogen to alkyl halide and obtain alkane. Let's see. So alkyl halides on reduction with zinc and dilute HCl gives alkane. So you are going to add hydrogen in presence of zinc and dilute HCl. So let's take the example here again, Rx, that is alkyl halide in the presence of hydrogen, in presence of zinc and dilute HCl. We are going to add hydrogen in presence of zinc and dilute HCl. You will get RH and HX. Now what is this? RH is the alkane and HX is the hydrogen halide. So let's take an example and understand this. C2H5Cl, that is chloroethane, right? The alkyl group here is ethyl group. So it is called as chloroethane or ethyl chloride, right? So it is going to react with hydrogen. We are going to reduce it, means we are going to add hydrogen in presence of zinc and dilute HCl. So now what happens here is, see, C2H5Cl and H2. You have 2 atoms of hydrogen here. So what happens is this Cl will be removed and one hydrogen atom will come and attack here. So it will be C2H5 plus one more hydrogen, it will be C2H6, that is your ethane, right? And one more hydrogen is here and this chlorine which will be removed, that will attach with the other next hydrogen. So what is that? You are going to get C2H6 and one more hydrogen from here and the chlorine which is removed from here, that will be present as HCl. So that's it. So I hope this is clear for you. Okay. So this is how you get the alkane. Right, and the corresponding hydrogen halide will be, if it was bromine here, you will get hydrogen bromide, HBr. Right, corresponding hydrogen halide you will obtain. The next one is from unsaturated hydrocarbons. Okay, unsaturated hydrocarbons means from alkenes and alkynes, we can prepare alkanes. So what you have to remember is, you have alkynes, you have alkenes, and you have alkanes. Okay, so this is the highest one, that is containing triple bonded system, right? So from alkynes you can prepare alkanes, from alkenes you can prepare alkanes, right? And from alkynes you can prepare alkenes, right? Okay, so from the higher one you can prepare the lower ones. So now we are going to study how from alkynes and alkenes we can prepare alkanes. Okay, so let's see, hydrogen gas adds to alkenes and alkynes in the presence of finely divided catalysts like platinum, palladium or nickel to give alkanes. And platinum and palladium, if you are using, they act as catalyst under room temperature. But if you are using nickel, we have to use it at higher temperatures. Right. So in this case also we are going to add hydrogen. That is, the process is called as hydrogenation. Okay, the process is called as hydrogenation. Addition of hydrogen is called as hydrogenation. And it happens in the presence of catalysts such as platinum, palladium or nickel. Right. So let's take the example of RCH double bond CH2. So you can see this is an alkene. Right. So this R stands for any alkyl group, and what we are doing, we are adding hydrogen in presence of nickel. So if it is nickel, I told you it doesn't happen in room temperature, it happens at 250 degrees Celsius. So what happens here is, once hydrogen is added, the double bond will be broken down. So what happens here is, you have two hydrogen atoms, right? So this bond will break, one hydrogen atom goes here, one hydrogen atom goes here. So what you will get, RCH2. Now two hydrogen atoms, RCH2, single bond CH3, right? RCH2, single bond CH3. So the double bond will become single bond and you will get your corresponding alkane. So let's take an example of propene. So the alkyl group is CH3 here. CH3, CH double bond CH2. Again adding hydrogen in presence of nickel 250 degrees Celsius. What happens? This bond will break, one hydrogen here, one hydrogen here. You will get CH3, CH2, right? CH2 and one more hydrogen here, CH2, CH3. Got it? Now again one more. This is alkyne. Okay, which one we have taken here? It is propyne. 3 carbon containing, so propyne. So what happens here is, we have taken 2 moles of hydrogen. Now why 2? Because in alkynes we have a triple bond, right? So first hydrogen gas, that is H2 molecule, will break one single bond. Again the next hydrogen molecule will break the next one. That is, from alkyne you will get alkene, then from alkene you will further get alkane. So that is why 2 here. So first one will be broken and you will get one hydrogen here, one hydrogen here. Another, the next one will be broken and one more hydrogen here, one more hydrogen here. So it will be CH3, CH2, single bond CH3, right? So you will get the propane. Got it? Yes. Now moving on to the next one, from monocarboxylic acids. Okay, so from carboxylic acid, the first one is by decarboxylation of fatty acids. Now what is decarboxylation? So wherever you see D, that means that it is a removal of something. So we just studied hydrogenation means addition of hydrogen. What if it was dehydrogenation? It means that it is removal of hydrogen. Okay, so what is decarboxylation? It means that it is the removal of CO2. Okay, so that is called as decarboxylation. So what is that happening here? Sodium salt of aliphatic monocarboxylic acid on heating with soda lime, which is a mixture of sodium hydroxide and calcium oxide, gives alkane. So what we are doing here, sodium salt of carboxylic acid. Okay, so let's take an example of a carboxylic acid, RCOOH. Okay, so what is sodium salt? This hydrogen will be replaced by sodium. So you will get RCOONA. So this is called as sodium salt of carboxylic acid. Now we are going to treat it or heat it with soda lime. So that is also important. Which is the reagent which is used in decarboxylation reaction? Another one is what is soda lime. So what is soda lime? It is a mixture of sodium hydroxide and calcium oxide, and we have to heat it. Okay, so we will get the corresponding alkane. So let's see, RCOONA. So this is a sodium salt of carboxylic acid, reacts with sodium hydroxide and calcium oxide, and this symbol stands for heating, right? So what happens here is this R and this H in sodium hydroxide, they will combine and form your alkane, that is RH. And what is left here? One Na here, two Na here, Na2, then COO here, which is removed, and that will combine with one more oxygen present here, and you will get Na2CO3. Okay, got it? So let's take an example where R is substituted as CH3. So this is a sodium salt of ethanoic acid, 2 carbon, right? So it is ethanoic acid. Now reacts with sodium hydroxide and calcium oxide, and we are going to heat it. What happens here? You have CH3 here and H here, which will combine and form CH4, right? You got your alkane. Now what is left here? Na2CO3, right? So the alkyl group and the hydrogen will combine and form the corresponding alkane. Okay. Now from monocarboxylic acid, first one is decarboxylation reaction. Now there is one more which is important, which is called as Kolb's electrolytic method. So you have reactions to study in anode and cathode, which is also important. So Kolb's electrolytic method. What is electrolytic method or electrolysis? Chemical reactions are going to take place by passing electricity through it. Okay, electro stands for electricity and lysis means breaking. So chemical reactions will happen by the passage of electricity. So let's see, when an aqueous solution means it is in the presence of water, right? Aqueous solution of sodium or potassium salt of aliphatic monocarboxylic acid is electrolyzed, alkane is formed. So let's take an example of, again, sodium or potassium salt, right? So this will electrolyze into CH3CO minus and K plus. It will be dissociated into this under electrolysis. So what happens at the anode? Anode is positively charged. So the negatively charged ion will go to the anode, right? And the positively charged one will go to the cathode. So anode is positive. So which is negative here? CH3COO minus. Acetate ion is the negatively charged. So now what happens? What is the reaction which is happening in the anode? This is important, right? So CH3COO minus, it becomes CH3COO radical. You are familiar with what is radical, right? So you can see here, it becomes CH3COO radical and one electron will be removed, right? So now this radical will further form CH3 radical and CO2 will be liberated. Okay, carbon dioxide will be liberated at the anode. Okay, now you have one CH3 radical. Further, this reaction will take place in several steps, right? So what happens is, again you will get CH3 radical. So two CH3 radicals will combine and form C2H6. So where is the electrode in which you are obtaining the alkene? It is anode. So the alkene will be obtained in the anode, right? Now at cathode, what happens? H2O. Okay, water is also present, right? So water breaks down into H plus and OH minus. Now as cathode is negatively charged, the H plus is the positive one, right? So it goes to the cathode. Now H plus accepts the electron which is left from here, removed from here. It accepts the electrons and forms hydrogen radical. Now two hydrogen radical will combine and form hydrogen gas. So what happened in the anode? In the anode, carbon dioxide gas was liberated, plus you got your alkane as well, right? Carbon dioxide and alkane. And at the cathode, which gas was liberated? And the cathode, you got hydrogen gas. So overall the reactions we can write. So the potassium salt of carboxylic acid in the presence of water undergoes electrolysis. It's an aqueous solution, right? So that is why water electrolysis and forms RR, that is the alkane, right? And carbon dioxide and hydrogen gas. Now there is potassium hydroxide also. Now where did this come from? So there is a K plus ion here by the dissociation of the potassium salt of carboxylic acid, and there was OH minus also from the dissociation of water molecule. So those two will combine and form the KOH. So I hope this reaction is also clear for you. So in the next session, we are going to study about the physical properties and chemical properties of alkanes. So I hope what all topics we have discussed in this session is clear for you. So that's all for today. Thank you.